Hi, today we talk about PID. PID sometimes is difficult to understand what's mean. First, I talk about the formula mathematics. After that, I give you a simple example how to understand this idea. PID means proportional, integrate, and derivatives. P is the proportional mode. Its formula is Kc times E. Kc is controller gain, and E is error. Error means the SP set point minus process variable, then got the error. Error sent to the controller. Sometimes some controller have your KB proportional band. Proportional band equal 100 to Kc. So if your proportional gain is too high, system is unstable. His laws change. If your proportional gain is too small, the system is too slowly responds to the system. So proportional is a big problem. Is have the always have offset. If you want to eliminate offset, we have to use integrate model I. This one's Ti is an integrate, or sometimes we call reset time. This way, reset time, the purpose of the integrate or reset mode is eliminate the offset. Also, most time we just use P and I to modify to PID. But sometimes if you're small, too slow, too fast, too slow to the response to the controller, so we use the derivative model. Derivative model is formula like this. We use the TD. TD is the derivative or rate time. Every time if your modified TD is too small, it's very small. So that's why it's because derivative responsibility is highly sensitivity to noisy, means the process variable signal. If your sensor feedback signal is noisy, or if the controller loop rate is too slow, the derivative response can make the control system unstable. So that's the PID. Most time we just use P and I. The PID formula look like this formula, but this is all the mathematics. But sometimes maybe you still don't understand something. Let me give you a simple example. This one SP. This process control how to work. Is PID control is PLC. Is just the SP. Is the sensor got the process variable. Is SP minus process variable got the error. Error go to the PID controller. PID controller got the result. Go to the controller output. PID controller just calculate use this formula. So go to the control output, this control variable. So then go to process system. So this one is in the RS logic 5000 we use PID. It's PID look like this. It's PID, and the process we should set up process variable, control variable, and the PID PID is the new tag. Then we need to set up a set point. Also, we can use PID, this function block. This is very powerful. Also, we can use its simple one, PI, just a proportional integrate. It's PI. PI is very simple, but sometimes it's very useful and enough for small, no conflict for simple controller. So it's PI, PID, PID. This all the RS Logic 5000, Studio 5000. We often use these three kind of control. So let me give you an example, very simple. P, what's mean P? P is proportional. For example, this is the tank, volume tank. If you have set point 30 in here, but if you use bucket, put the water inside. This uses a big bucket. This is called proportional. Again, if you a proportional controller, if every time put the one bucket going inside, but you can't exactly reach this set point 30. After that, maybe a little bit low or a little bit high. So this is called P. A little bit low, a little bit high. This is called offset. Okay, if you are no good, if you still have offset, we have to use I. What's mean I? I look like a small bucket. If you use small bucket, put the water in the tank, so it's easy got the 30 is a set point. But sometimes it's still slowly, because this one very small, it's slowly. So in the family, we can use Hawk's water house. Water house, put the water, is continue, put the water goes there. This is called derivative. This just give you an example, it's not exactly idea. Sometimes, yeah, it's good. You could understand this PID. Another example, just curling. This ice spot curling. This look like PID. This guy is look like P. He's hit the what's a stone. Go here. He always have offset to destination. So these two guys just to make sure he's eliminate the offset. This guy just look. These two guys look like I. This guy look like P. This guy look like D. Make sure he's faster go to the destination. Okay. This one just PID explained simple. So most time if you're in the side, sometimes you don't need do something. If you don't understand the PID, you don't know how to use. If you have the stand alone is a controller, if your adjustment this controller, for example, if your temperature controller, if you're tuning, you have to P and I and D. Sometimes you don't know how to tuning. You can choose auto tuning. Auto tuning is the system automatic. It helps you to do everything. It's okay. So yeah, most of the time we use temperature controller. We just use P and I. and every company, the controller, he has the menu. He tell you how to adjustment modify the P and the I and the D. Should is the range, what's the modified range? That's all this my PID. Thank you very much.